Howdy, Mission Control. Well, tonight we're going to actually start taking down, this is lane 2, one of the original lanes that we put up last year. And we're going to be taking out the automation that I put in so we can start making way for the new automation, which I'm going to show you. I've got a big shipment in and I'm ready to start building it. It's going to be a pretty simple build because I'm just going to put the valve control automation back in to start with. We're going to add back in some of the light control and other features that we had before once we get the shelving in September, and the lighting really has to go up. So this is kind of a bittersweet type of event where I got to come in here and take apart stuff that took me a while to put together. And so like I said, it's kind of bittersweet because yeah, you got to take it out, but by taking it out I know that I got to put something in that's better, so that's what makes it sweet. And the new solution has significantly less complexity in it, meaning we have a lot less moving parts. It's going to be safer. We're going to split out the high voltage and the low voltage. Just some of the mistakes I made because I didn't know, how to do everything perfectly. So that's going to be nice, getting it all fixed up. But it still kind of sucks, putting it all together and then having to take it all down. But that's learning using the agile method. Sometimes you just have to build it to get going, and then you learn and you make improvements, and then you keep going. That's what we're doing. Keep moving forward. You look at these, the original stuff that I built, how messy that is. I've learned so much since then. I could have made a custom circuit board. I could have done different wires, different connectors, got the high voltage out of there. We're going to do a lot better on the next round. I just got done taking apart, I took down all of the automation boxes, so now I got to remove the lights. Now these lights I got to figure out what we're going to do with, because either we're going to reuse them and then have to buy more of exactly the same type, or I'm going to sell them, Craigslist baby, and try to get some money back for them. So if you're interested and you live up in the Oregon, Washington area, shoot me an email at trm@TheRealMartian.com. I got a lot of them. Lots of lights. Now it's time to take down the boards. Now on these boards, they were put up because they were the cheapest thing I could find that would actually hold the lights. Looking at a few bucks for the boards, and then you just put this track underneath. But in the search for our new lighting solution, been hard pressed to find anything that even comes close to the same cost as wood and is easy to work with. But the wood, it can get mold and stuff on, and ours did. So we're getting it all out of here. We could do wood again, but it'd have to be painted, and that's probably the simplest solution. Then it's just a matter of how do you mount it up higher onto these. We'll have to put a cross member on there and then just mount everything to it. So probably not that big a deal, but something we have to deal with. And just like that, a lot of work is now taken down. Like I said, kind of bittersweet. This is a little bit more the bitter part. Well, we got it all down. And like I said, next step, I got to go inside and actually build the new control units. And we're just going to do one control unit for that entire lane. So each one of those individual control boxes that I took down, I'm only putting one back up. This is going to do a few things for us, but in particular, it's going to use a little less power. Those things didn't take a lot of power, but it's going to, every little bit matters. So we're going to get some juice back. And then instead of having, on this lane, there's 5 beds. Instead of having 5 points of failure, we're going to get it all down to 1 that we can make redundant if we want to as well. So it's going to be a lot simpler system. And the code's going to be a lot easier as well to write for this, because instead of having to coordinate 5 different units and what they're all doing independent of each other, which isn't hugely difficult, but it did prove to be a little problematic, getting them all to sync and do the exact same thing when they're supposed to. When we get to the new unit, it'll be one master control unit controlling all the relays, and it'll know what relay is going when, so the code becomes a lot easier, saves time and energy there, making things simpler. All right, well, let's head on inside and see what the delivery looks like and get started on building these units. We just got done taking everything down. We're actually going to harvest parts off of these. Going to try to reuse as much as possible, minimize our cost. But tonight I wanted to actually go over kind of what the game plan is. Reduce that down a little bit here. Okay, so we have 4 lanes. Lane 1, lane 2, lane 3, and lane 4. Now, lane 1 and 2 are 5 beds, and lane 3 and 4 are 4 beds. Previously, we had 5 controllers on lane 2, and then we had 4 controllers on the lower beds of lane 3, and we had 3 controllers on the upper beds of lane 3, because we didn't have all 4 beds built on the top. So what we're moving from, that's, what is that, 7 and 5, 11? Sorry, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, 12. Good. It's late, and I'm doing math in public to the entire planet. Probably a bad idea. Okay. Anyway, we had 12 of them. What we're moving to, getting to the point, is a single control unit for each lane. So instead of having 5 control units here, we're actually just going to the single 1 control unit. So let's pivot on that and see what we're going to do for it. Okay. So here's my single lane. And then I have my control unit in the middle. Now we have some lessons learned from last year that we want to apply here. First, we're going to put the computer in here, so the CPU will be there. Now that's going to be the Arduino Mega. This is the Arduino Mega. It has a whole lot of digital I/O right here, and it has a bunch of analog I/O right here. And as far as cost goes, this thing costs roughly the same as the other one that we're using. And in order to make it Wi-Fi, we're going to have to add an ESP8266 chip. I actually ended up, these are actually just 2.4 gigahertz radios, so I got a bunch of these accidentally. I thought they were Wi-Fi, and I didn't read the instructions close enough, which I'm really good at not doing. So we'll be connecting the ESP8266s to the Mega. That'll give us Wi-Fi, and then each of these lanes will be Wi-Fi controlled, just like what we had before. Unlike what we had before, we're actually going to separate out the 120 volt bus. So all the relays for the 120 volts will actually be powered in a separate box. So if something goes wrong here, minimal chance it's going to impact anything over here that has a low voltage in it. Speaking of low voltage, inside of this CPU box will be a 12 volt power supply. So what we're going to have to do is we'll run AC power in. We'll run AC power in, and we'll run that to the 12 volt so that we have a 12 volt power supply. And then we'll split off of that and bring AC over here. We'll also bring 5 volt power over here to turn on the relays that we'll have over there. Then I'm going to keep, this box will be low voltage, so we'll have all the 12 volt relays that we need to have. I'll draw that picture next. Will be coming in this box. All the 120 volt relays, which are our lights and our motors that move the lights back and forth, they'll all come off of this one, but these two boxes will be connected to each other, so it'll be a lot safer than what we had before. So now let's talk about what we actually need to control. So here's a bed, here's a bed, there's a bed, and if you have 5, there's a bed. So each one of those is a actual grow bed. And the grow beds really, different color here, are divided into two pieces, two halves. On the lower half are the aquaponic beds. And each of those aquaponic beds will have a 12-volt valve that will control it. So aquaponics is 12-volt valve. So each one of those will be controlled by one of the 12-volt relays that will go into the main control unit. Let's see here. Then, for the aquaponic bed itself, you'll also have a 120-volt relay for each one of them. Looks like my red is dying here. This is going to be a different, better color. Oh, there we go, something like that. There's a 120-volt relay that'll control the grow lights that are shining down onto the aquaponic bed, as well as the motor, if we go that way, that controls them. So it'll all just turn on at the same time. And then you have your next shelf, which is the germination shelf, and it doesn't have any lights. Then you have the next shelf on top of that, which is your microgreen shelf. So on the microgreen shelf, you're going to have 120 volts as well for probably a motor and the lights. So then, this means that we'll have, let's see here, microgreen 120 volt, oops, microgreen lights, I guess we should say, equals 120 volt. And then we have aquaponic lights equals 120 volt. And then for a 5-lane or a 5-bed system, you're going to have 5 and 4, 5 and 4, 5 and 4, for each one of them. So we'll end up having 8 total 120 volt relays, and we'll have 4 12 volt relays that need to go to the main control unit. So the main control unit is going to be these guys here. So the original prototype I had way long ago, where did I put it? It's over here. Over here. This is the original prototype that I made that went into the office. Actually, right here used to be a fish tank, and it had the aquaponic system. It was pretty cool. And actually had all the sensor inputs right here. Had a 12-volt bus right here. I had an AC power in with a switch. That was pretty cool. And then I had all my AC power over here. What I learned about this is cutting these things is absolutely horrendous. So I'm moving away. I'm going. All my stuff needs to be round because you can drill it. But these really suck to make, and I don't want to do that again. That was a lot of long, tedious work. And then inside, it's kind of been gutted right now, but you had your 12-volt relay, 120-volt bus, 12-volt bus, and you had Ethernet and a USB control here, where you can plug everything in and reprogram and do all that. So that's the original prototype. Now we're moving away from that. We're going to use the same box, and then these are going to be the 120 volt relay boxes here. And then I got the actual, what are these called? They're wire bites or wire clips. So then these are nice round clips that you just run all your wires into here. It screws in real nice. So what I need to get doing here is I need to strip down these old boxes here, get all of my parts back. I'm going to have 12 Arduinos that I'm going to be able to repurpose. So I think I'm going to automate everything. I don't know what that means, but I'll have plenty of ability to do it. Get all my plugs and everything back here, and there's some relays in here I can harvest. There's 12-volt power supplies I can harvest that are wall warts, just repurpose. There are lots of connectors, lots of wires that I can get back. So I'm going to do that. And then I'm going to mount the Mega. Is going to get mounted in here. Like so. And then the ESP is going to connect to it somehow. And then we'll have our power supply mounted in here. And probably put that all right down the middle, I think. 12 volt here, computer there, and then that gives me the edge here for 12 volts, and it gives me this side over here with the punch outs, so I can actually run the 120, and then I can bring 120 in, probably bring 120 in right there, and then take it back out that side right there, and yeah. So that's the game plan, and to build these is actually going to be somewhat easy, I hope. I hope you enjoyed watching this video. If you did, be sure to give us a thumbs up and hit subscribe. You can also follow us on Facebook and Twitter. In the meantime, everyone, this is The Real Martian. Out.